All right, every now and then you're going to run into a problem where you're going to have to use parts more than once. Pay attention to what you're doing, keep track of all your minus signs, and you're going to be just fine. Now, remember how we're going to pick a u and a v right here. We're going to try and find something that when you take the u and you take the derivative, it simplifies, and when you take dv, it kind of stays the same. So let's real quick remember how this all works. U dv is equal to u times v minus the integral of v du. Okay? All right. So I'm looking for like a natural log right off the bat. I don't see one. I'm looking for inverse trig right off the bat. I don't see one. I'm looking for a polynomial for u. I see one. So we're going to let u equal x squared. And then that would mean then that this guy right here, e to the x, would be my dv. So if I substitute u in for x squared and dv in for x, my new function is going to become, my new integral is going to become the integral of u dv. Hey, we just discovered that right here. So what I need is u times v, but I don't have v, so I'm going to integrate these guys. All right? And when I integrate these guys, it's going to give me v equals, and e to the x, quite frankly, is a really nice jack of all trades, okay? When you integrate e to the x, it's e to the x. When you take derivative of e to the x, it's e to the x. So this guy's actually pretty nice to have in our problem because we can usually go either direction with him. And he's still manageable, e to the x, okay? So I've got u times v. Okay, right here, x squared e to the x. So right here, x squared e to the x minus the integral of v du. Well, I've got v, but I don't have my du. So let's see if I can figure out which color I had here. So du is going to be 2x dx. Did you see what I did? Did you see what I did? I did 2 for the price of 1. I went ahead and multiplied both sides of my equation by dx right here. So now that gives me 2x dx times e to the x. All right. I'm going to have to do parts again. How come? Because this guy right here doesn't integrate to something that we already know. Okay, he stays kind of complicated. So we're going to do parts again, and we're going to pick a u and a v again, and we're going to work with the integral of 2x e to the x dx. Okay, and I'm going to allow this guy right here to be my u. And if you pick dv to be e to the x, then if we have to do integration by parts more than once, always pick dv to be e to the x. All right, so now what we're going to do is take the derivative of the u. All right, so that's going to be du equals 2 dx. We're going to integrate dv. And we love this one because when you integrate e to the x, it's e to the x. All right? And so back over here now, I'm going to have x squared e to the x minus, and then I integrate this guy following my integration by parts rule. So I've got a new u and v. So 2x e to the x minus the integral of v du. v du. And now this guy is a lot easier to work with, okay? This integral right here, 2e to the x, is not bad because we can bring the 2 in front of the integral. And e to the x integrates to e to the x. We've just done that one twice already. So my next step in simplification would look like this. I don't know why my lines are getting shaky over here. would look like this right here. When you integrate 2e to the x, 2 is a constant and it can move in front of the integral. E to the x integrates to e to the x. So what have I got for my final answer? Well, there's a couple of different ways to write this. You could write this as x squared e to the x minus 2xe to the x minus 2e to the x plus c. You could write it this way. Sometimes if you look in the back of a book, or if you're checking your answer online, or if you have a professor that likes to see things a little cleaner, you'll notice that there's an e to the x in each part here that you could factor out if you wanted to. I don't necessarily expect you to be able to do that, but it's something that may or may not need to do at some point. So I just point that out, that is a possibility. I'm not going to make you do it. But there you go. So there's integration by parts more than once. And the key here is this. When you have to integrate by parts more than once, whatever you pick as your dv has to remain your dv the entire way through the process. If it doesn't, you're going to wind up back where you started with your original problem, or you'll end up with a problem that just doesn't seem to go anywhere. So if that's happening with you on an integration by parts problem, double check and make sure that you're using the same dv every time you integrate.